Alright, we're talking about special segments in triangles. There's 3 that you need to get written down and that we're going to be practicing. They are median, altitude, and mid-segment. As you can see here, it says that the median of a triangle is the segment from a vertex to the midpoint of the opposite side. And here is an example. Okay, in blue, this is the vertex, or the corner of one of the triangles. When you connect that vertex to the opposite side's midpoint, okay, being the center of that opposite side, this segment is called the median. Okay, notice that we have tick marks showing that M is in fact the midpoint of side YZ. Okay, so a median is connecting vertex to midpoint. Okay, the second line segment is an altitude, or a height of a triangle, and it is perpendicular. If you don't remember what perpendicular is, you need to make a note. Perpendicular means that it forms a 90-degree angle, okay, with a segment, it's a perpendicular segment from a vertex to the opposite side. So same as median, vertex to opposite side, but it's not necessarily to the midpoint. It's anywhere on the opposite side or an extension of it, okay, that forms a 90-degree angle. And you can see here in this acute triangle, ABC, okay, if you connect it to the opposite side, we'll call this point L, a 90-degree angle. This is not, L is not the midpoint, obviously. This is much shorter than LC. Okay, in this triangle ABC, where you have an obtuse angle, okay, for it to connect inside the triangle, none of those places would form a 90-degree angle. So for it to form a 90-degree angle, it's going to be outside the triangle, okay? That's where this or an extension of it comes into play. So this dotted line extends this side BC out so that A can meet it, and that is the altitude. Okay, here's another one where it's outside the triangle. If you actually have a right triangle already drawn, and I can draw one for you to see it in a right triangle, and you're asked for the altitude of the right triangle, well, this angle in the triangle is 90 degrees. So if you went from here to here, you could call this the altitude, okay, or if you're coming from this vertex, this could be the altitude. Okay, either one of those could be the altitude. Okay, so it's from the vertex to the opposite side, wherever it happens to form a 90-degree angle. It can be inside the triangle, it can be outside the triangle, it can be a side of the triangle, depending on if it's acute, obtuse, or right. Okay, the third one is a mid-segment. Okay, the mid-segment of a triangle is connecting 2 midpoints. Okay, so here P and Q are midpoints. P is the midpoint of JL, and Q is the midpoint of KL. Okay, notice the tick marks there showing us those are midpoints. When we connect those, this line segment is called the mid-segment because it's midpoints connected. What you need to know about mid-segments are that they are parallel to the third side. So the sides that they are not connecting, that this is the third side that it's not touching, they're actually going to be parallel, and I've drawn the arrows on here to show you parallel. Okay, and this statement tells us that PQ, this mid-segment, is parallel to JK. You also should know that the mid-segment of a triangle is going to be half the length of that third side. The sides that are the side that it's parallel to. Okay, it's going to be half that length. So for instance, if JK were 12 centimeters, PQ would be 6 centimeters, because PQ is half of JK. I drew in this down here just so you would notice if you are given an isosceles triangle, that means 2 sides are equal. Remember, we talked about the different parts of isosceles triangles. These are the legs, the 2 that are congruent, and this is called the vertex angle. When you draw the median from the vertex angle, okay, so median connects to the midpoint of the opposite side. Okay, so here's the midpoint. it is an altitude. It creates a 90-degree angle, okay? It cuts this side in half and creates a 90-degree angle, and it also cuts this vertex angle exactly in half. But that's only in an isosceles triangle, okay, when you're coming from that vertex angle. Or in an equilateral, coming from any of the sides. The median would be an altitude and bisect the angle. Okay, so that's kind of a special case for those isosceles and equilateral triangles. Okay, let's try just a couple of problems to make sure that you're getting that vocab down. Alright, so in this first triangle, this is an obtuse triangle, QRS. Okay, we have T, V, and U marked with these tick marks showing us they are the midpoints of these different sides of the triangle. Okay, Q, U. If we're to connect Q to U, that would be what type of segment? A vertex to a midpoint, and you should say median. Okay, it's not an altitude, it doesn't create a 90-degree angle, and it's not a mid-segment because it's not connecting to midpoints. Okay, TV, if we connected T to V, those are both midpoints. When you connect two midpoints, that is a mid-segment. Okay, here we have an acute triangle ABC with EF and G marked as the midpoints. Okay, they ask that what is FB? So if we look from F to B, B is a vertex and F is the midpoint on the opposite side. Okay, so again that would be a median. Okay, now they tell us if GE, so let's look at GE, okay, that is a mid-segment, midpoint to midpoint. You need to remember that that is going to be parallel to the third side. Okay, so those two are parallel. So if G to E is 12, how long is A to C? Okay, remember this mid-segment is half the length of the opposite side, the one that it's parallel to. So 12 is half of what? So you would say 24. Okay, then AF, well notice this has 2 and 2. F is the midpoint, it's cutting it in half. So if it's 24 all the way across, AF would also be 12. So the two halves of that third side are going to be equal to the mid-segment. Alright, in this bottom one, this right triangle, it says that LN, so LN is 18. So this entire length is 18. So how long would HJ be? Okay, well it should be half because it is a mid-segment and that is the side that it is parallel to. So you'd say 9. Okay, MI, if we connect M to I, that is a vertex to a midpoint. That would be a median. How about LM? Okay, so L to M, that's just two vertices, but if you notice, side LM creates a 90-degree angle with another side. So not only is it a side of the triangle, it is an altitude of the triangle, or the height of the triangle. Okay, so those are the three big vocab words that you needed to get down and know the little attributes of. Okay, we're going to be doing some practice with those, so make sure you have those down.